Alright, I believe we're recording. Let's take a look at the solution to problem number 12. And again, we need to know this order of transformations in order to do it. This is like the Please Excuse My Dear Aunt Sally. When you have several transformations, the order becomes important. First, you'll want to do horizontal shifts left or right. Then you'll want to do horizontal compressions, which means horizontally stretching the graph or horizontally shrinking the graph. And within that step 2, the order is interchangeable if you have a reflection across the y-axis. Then in step 3, you want to do your vertical compressions, which is vertical stretches and vertical shrinks. And if you have any reflections that are across the x-axis, within that step, you can do those in either order. Then finally, you want to do your vertical shifts, which are up or down. So let's take a look here at this function g. We have a parent function here, f of x, that is the square root function. Okay, and we're going to transform this square root function through a sequence of transformations into this new graph. So my first transformation, do I have any shifts to the left or to the right? That +1 is a shift to the left. It's bizarre in its behavior, so I know that I am going to take the parent function and shift it to the left 1 unit. That would look like the square root of x plus 1. So let's describe that transformation. So over here to obtain the graph of what we're calling G1, we shift the graph of f, our parent function, our square root function, to the left 1 unit. Now, we'd like to take this resulting graph and do another transformation. Let's take care of this 3. I'm going to take care of that negative last. Let's take 3 times the previous graph. And notice this time it's on the output. It's on the outside of the radical. It's not underneath the radical. So you're using the output, the result of the square root function, and multiplying it by 3. So this would look like 3 times the square root of x plus 1. So to obtain the graph of this function that we're calling g sub 2, we vertically stretch, and I know it's a vertical stretch because 3 is bigger than 1. If it was a 1/3, 1/2, it was some proper fraction, it'd be a vertical shrink. But this is a vertical stretch by a factor of 3. Vertically stretch the graph of G1, the previous graph, by a factor of 3. See, you're not going back and starting over. These graphs are building on each other, and that's very important to understand. Alright, so now let's take care of this minus sign. Our final graph that we're going to call G is to take the opposite of the output of this function that we've called g of 2. So what that looks like, if g of 2 is this 3 times the square root of the quantity x plus 1, this is negative 3 times. So I've taken this parent function that was the square root, and I've built it through transformations to this final graph that we're interested in, this negative 3 square root of x plus 1. This we're calling our final graph G. We reflect the graph of our previous graph we called G2, and the negative on the outside is changing the sign of the y coordinates, changing the sign of the output of the function. So that's a reflection across the x-axis. So we reflect the graph of G across the x-axis. All right, so this parent function is the square root function. Now again, like my problem number 11, if you didn't watch that video, I'm going to jump over to the Desmos graphing calculator to illustrate that I've done this correctly. So my previous problem is probably still on there. So let's get rid of it. And my new parent function here is the, do I have a square root symbol? Yep, square root of x. Okay. Now, to see that graph, I need to toggle this on. So that circle right there needs to, there you can see the graph. If I click it, it turns it off. So here's my square root function, and the first thing that we did was shift it to the left 1 unit. So, oops. So this first graph is going to take the parent function, and shifting it to the left is actually plus 1. Yeah. And we can see that did shift the graph to the left 1, which is, I always thought that was bizarre in the behavior. You know, in the past, in word problems, whenever anything increased in value, or if you had x plus 1, it moved to the right. But this is counterintuitive. When you're affecting the domain, it's bizarre in its behavior that it shifts to the left. All right, now this next graph is a vertical stretch. So this next graph, and it's not a vertical stretch of the parent function, it's a vertical stretch of the graph that we immediately got above it. It's a vertical stretch of this G1. Let's make sure that it was by vertical, yeah, of 3. Okay, so we started with this square root function, and we transformed it to the left. And now we're going to vertically stretch that graph to here. And you can see the y coordinates now are further away from the x-axis. They were stretched away from the x-axis. Here, when x equals 3, the output was 2, and now the output is 6, because 3 times 2 is 6. It got vertically stretched. Well, now we're ready for our final transformation, which was a reflection. So our G is to reflect our previous graph that we called 2. And you can see, if I make this bigger, that, well, maybe I need to zoom out a little bit, that I was building upon this graph that's here in red. That negative sign reflected it across the x-axis, which is exactly how we described it. We described it would be a reflection of the graph of G2 across the x-axis. Now, how do I know that these transformations, that this graph right here that's in blue is the final graph that they wanted? Well, imagine you didn't even know anything about these transformations, and you just came in and you graphed this function. the function was -3 times the square root of the quantity x plus 1. So there it is in green right there. And is that the same graph that I had just a minute ago? Let's toggle that on. Let's change the color so you can see it a little bit better. Let's see if the orange shows up a little bit better. If I turn off the if I turn off the orange, there's the green. If I turn off the green, there's the orange. So there's the answer that we had after we transformed it, 3 things. And here is the graph if you didn't even know anything about transformations and all you did was just graph this function. There it is in green. It's the same as how we built this function. We started with a square root function. We shifted it to the left. Now, I've zoomed out so far that we shifted it to the left. Then we vertically stretched it by a factor of 3. And then we reflected that across the x-axis. And we got the same graph that we would have had we just graphed that -3 times the quantity x plus 1. So hopefully that helps.